Hello, yeah, in this video, I want to talk about how to assess the stability of clusters in the cluster analysis using the ClusterStability R package. Uh, yes, I keep looking for R packages for assessing stability of clusters, and this is the one I found and tried, and it works. Okay, so let's load the necessary library, called the ClusterStability and mass and ggtoplot. So I already installed them here, so I just load them in and random seed. So n equal to 100, and we have 3 mean factors and a covariance matrix. Then we'll use the multivariate normal distribution function in the mass library to create 3 clusters, combine them together, give them column names, and we have the true labels here. And this is the data structure, okay? And we can plot them out. You can see that I choose the mean vectors and covariance matrix so that there's some overlap of the data points. So we're not cheating this time. The 3 clusters are not obviously separated. Okay, so we can set another random seed. Say we start with 3 clusters, and then we use the k-means function to do the cluster analysis, and we assign the data with the cluster variable from the k-means result. Okay, and then we can plot them out. Um, they are marked in different colors. There's 3 clusters. Okay, and to assess the stability, we use the ClusterStability function. You can see we can actually let's okay, so this is the help function. You can see it's quite simple. You have the data, the number of classes, and then the replicate is the number of replicates to perform. Default is 1,000, and type is the algorithm used in the partitioning, either k-means or k-modoids algorithm. Okay, the default is the k-means. Okay, so it's relatively simple, but it's really for the k-means clustering. Okay, so here I use just 100 replicates here, and then we get the stability result. If we print them out, you can see there are several objects here, several things. It looks like stability result is a list with stch and stsio, stdone, and stdb. Okay, so if you wonder what they are, so I have some notes here. These are 4 types of stability scores. They call the Kalinsky-Hara-Base, Seal-Hote, Dunn, and Davis-Baldin. Okay, so these are the person who developed these scores. And for these scores, we have individual scores. They are ST, SCH, ST, SIL, ST, Dunn, and STDB. And we also have a global score. So ST global, CH, ST global, SIL, etc. These scores range from 0 to 1. The closer to 1, the better for stability. And usually, rule of thumb, we hope to see larger, greater than or equal to 0.75 to consider to be stable clusters. Okay, So here, if we look at these are for each individual data point that has a score. There's the individual score, and then we can do a summary. So it's a numerical um, summary. So the largest is 0.87. That's good. And the lowest is 0.24. So if we plot them out, they look like that. And so if you look at these points, those close to 0.9, these points are very well clustered. But then you also got some closer to 0.5, 0.6, that kind of belong to the overlapping areas of the clusters. You can also plot out the histogram to have some idea about the distribution of these um, stability scores. Okay, so from the stability analysis here, we know the overall, see the global scores, they're all above 0.75, so it's okay, it's acceptable, but there are some points that may be difficult, for the clustering analysis. Okay. All right. This is another way for performing stability analysis of clusters in a cluster analysis. Thank you.